Precalculus, Chapter Prerequisites, Section 6, Rational Expressions. I'm going to go through a lot of material very quickly, so you'll probably want to pause this video often so you can get down all the notes that you need to. A rational expression. This is a quotient of two polynomials. You've worked with these before in Algebra 2. When we talk about domain, this is the set of values for the input that give real number outputs. In these problems, you're going to talk about domain excluded values, and these are values for the input that would give a non-real or undefined output. For rationals, what you need to be concerned with is a denominator of 0. So let's talk about excluding numbers from the domain. So you want to find all the numbers that must be excluded from the domain of the rational expression. And if you look at that expression 7x, that's a polynomial, it's a monomial, over x squared minus 5x minus 14, that is also a polynomial, a trinomial. So to find out, what we need to do is examine that denominator. When I do, I notice that it is a quadratic trinomial, and I can break it down into its factors. So I think about two numbers that will multiply to give me negative 14 and will combine to give me negative 5, which is negative 7 and 2. So my denominator is x minus 7 times x plus 2. Now I can see easily what values for x would make my denominator 0. I can set each of those factors equal to 0 and solve. And see that if I had x equaling 7 or if I had x equaling negative 2, then I would get 0 in my denominator. So we have to exclude those values from our domain because we do not want to get 0 in the denominator. That is an undefined expression. When you simplify rational expressions, a rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. So the following procedure can be used to simplify rational expressions. The first thing is you need to factor the numerator and the denominator completely and separately. Then you need to divide out any common factors in the numerator and the denominator. So let's simplify this rational expression. X squared minus 1 over x squared plus 2x plus 1. Let's factor the numerator. I notice that's a difference of squares, and so it will factor as x plus 1 times x minus 1. I notice my denominator is a trinomial. Two numbers that I'll multiply to give me 1 and combine to give me 2 are 1 and 1. So it will factor as x plus 1 times x plus 1. Now before I simplify, I'm going to look for excluded values. So I have a repeated expression in my denominator. I set that equal to 0, and that shows me that if x is negative 1, I will get 0 in the denominator, so we need to exclude that value. Now to simplify, you'll take your rational expression, x plus 1, x minus 1, over x plus 1 times x plus 1, and we'll divide out common factors. These are expressions that are exactly the same. We can divide out one pair of x plus 1. So our final simplified rational expression is x minus 1 over x plus 1. And then we include our excluded values, our domain exclusion. We say x cannot equal negative 1. And together, that is our answer for our simplified rational expression. When you're multiplying rational expressions, there's a process to use. First, you're going to factor all numerators and denominators completely. You're going to divide out common factors in the numerators and the denominators, and then you'll multiply the remaining factors in the numerator and then the remaining factors in the denominator. So when we multiply rationals, we multiply straight across. So we're multiplying these two rational expressions. The first thing we want to do is factor any of our numerators or denominators. Our first denominator is a difference of squares. It'll factor as x plus 2, x minus 2. Our second numerator is a trinomial, and it will factor as x minus 3 times x plus 2. And our second one will factor as x plus 3 times x plus 3. Now before we simplify, we're going to look for the excluded values. And so that's anything that will make our denominator 0. So let's take all those expressions from our denominator, set them equal to 0, and solve. So x cannot equal negative 2, x should not equal positive 2, and then we only need to do x plus 3 once. So these should be our 3 excluded values to include with our answer. Now to simplify, go up to our problem, and you can divide out any numerator with any denominator. So our x plus 3, those divide out, and our x plus 2's divide out. We're left with x minus 3 in our numerator and x minus 2 times x plus 3 in our denominator. And then we include our excluded values, which are negative 2, 2, and negative 3. So when you're dividing rational expressions, the quotient of two rational expressions is the product of the first one and the second. And the reciprocal of the second expression. And remember, a reciprocal is found by interchanging the numerator and denominator or by flipping that rational. So to divide two rational expressions, first you're going to do, you might have learned this as keep, change, flip. So you're going to keep the first rational expression, you're going to change division to multiplication, and then you're going to take the reciprocal of the second one. You're going to flip it. Then you'll factor all numerators and denominators, check for excluded values, multiply, and simplify. So let's divide in example 4, these rational expressions. So remember, the first thing is we're going to rewrite this as multiplication. So we keep our first expression over x cubed plus x. We change to multiplication of the reciprocal. So see how we're flipping our second rational. Now we're going to factor any of the numerators and denominators. So the first one is a trinomial, and it factors as x minus 1 times x minus 1. And I can factor out just an x, a greatest common factor. In the second expression, numerator, I can factor out a 3, and then our denominator is a trinomial, and it will factor as x plus 2 times x minus 1. Now I'm going to check for my excluded values before I multiply. And I'm looking for any values of x that would give me real numbers. So x cannot equal 0. Now notice my second denominator is x squared plus 1. When I solve that, I get x equaling, so I get x squared equals negative 1, and then if I take the square root, that would give me the square root of negative 1, which is not, it's non-real. So I don't need to worry about any value for that expression. X plus 2 means that I need to exclude negative 2. And then finally, x minus 1 in our denominator means I need to exclude 1 for x. Now go back up, and we are going to divide out any common numerator and denominator expressions. And we'll write what we have left, which is 3 times x minus 1 times x plus 2. And then we'll list our excluded values. We really do not need to multiply that 3 back to distribute it or to distribute the x. We can just leave our answer, our final answer, in factored form. So when you're adding and subtracting rational expressions with the same denominator, remember, first you're going to need to add or subtract the numerators, place the result over the common denominator, and simplify. Also, check for values that you'll need to exclude. So we're subtracting x over x plus 1 minus 3x plus 2 over x plus 1. We already have a common denominator, so now we can just first check for excluded values. So we have this one expression in our denominator, solve for x, so x should not equal negative 1. Now I'm just going to subtract my numerators. So I have x minus the quantity, because I have to subtract each parts of this, of 3x plus 2, all over that one common denominator. Now I'm going to distribute my negative, and then I'm going to simplify my numerator. So I get negative 2x minus 2 all over x plus 1. One last thing I notice is that I can factor out a negative 2 from my numerator. And I do this because sometimes I'll be left with a common factor I can divide out, which we are. See, we can divide out the x plus 1s. So our final answer is -2 with the excluded value that x cannot equal -1. All right, I am going to stop this video, and then in part 2, we will cover the rest of our material that we have with rational expressions.